Hi there, Physics 152 students. I hope you're all doing well. This week in Practicals, we'll be doing something a little different. You will be writing 2 Python codes from scratch, meaning that no starter code template will be given to you this week. First, let's take a little look at the physics. So, chapter 17 from Night is simply entitled Superposition. And it starts with the principle of superposition. When 2 or more waves are simultaneously present at a single point in space, the displacement of the medium at that point is the sum of the displacements due to each individual wave. So your goal in Practicals this week will be to submit to your TA 2 working Python codes. Activity 1 is to make a history graph showing the superposition of 2 sinusoidal waves that have identical amplitude but slightly different frequencies. Your graph should visually show the phenomenon of beats. Activity 2, you know that standing waves can be thought of as the superposition of 2 identical sine waves traveling in opposite directions. Produce an animation which shows the 2 underlying traveling waves and the resulting standing wave. Okay, so if you've had lots of experience with Python, these activities might seem pretty straightforward. But there's always more to learn, and there are plenty of students in this course that are quite new to Python, and that's great. So, I have teamed up with a U of T computer science graduate named Mark Kazakevich to write a 12-page document called the Waves Animation Module Student Guide, which will lead you step by step through these 2 activities. Along the way, this module is also designed to introduce you to some important concepts in Python that can be useful in your physics career, such as arrays, known in Python as lists, loops, functions, and methods. Along the way, of course, you'll be importing functions from external Python libraries and modules, which allow you to do math, plot graphs, and produce a simple animation. Since this is such a different kind of practical this week, there will be no presentations. So the practical is out of 14 points instead of 17. Also, you will not be working in your normal breakout rooms this week. Your TA will be pairing you up, or allowing you to work alone if you prefer. Teams of 3 are allowed, but no teams of 4. In order to help best split you into pairs, the 6th question on the quiz this week is, how would you best describe your background with Python outside of this course and Physics 151? Please answer honestly. Okay, that's pretty much it. So for the rest of this video, I want to go to my computer and walk you through how to write a Python code from scratch. So if you're already an expert on Python, feel free to skip the rest of this video and go do the quiz right now. Alright, so I always start by opening up this Spider Anaconda. And this opens up your Spider window, which has your editor where you'll type your code. I'm just going to get it started with number 1 there. This is a upper right-hand corner is where there's usually where the plots go and things. And down here is called the console, where the code gets run. So I'm going to start with a comment saying that this code was written by Jason Harlow on March 10th, 2021. And another comment, again, anytime I start with a little hashtag, it means it's a comment. First, let's import every function in the Numpy library. So Numpy, we would do that is we would say from Numpy import, instead of just taking functions, I'm going to use a wildcard there. I think I get a little exclamation point which says, you know, it doesn't like the wildcard. You should use just the functions, import only the functions you're going to actually use. But I don't really care about style in Python, so I just import everything. Okay, so let's do some examples. Let's first try multiplying two numbers. Okay, so I'm going to say that A equals, let's call it 6, B equals, I don't know, 7.1, and then C is equal to A asterisk B. That means times. So if I print now, do a print of, let's do an open quote here, A times B equals, and then space, and I'll put a comma C. So now I want to save this, Control S. I'm going to do actually save as. Put it in here, choose my folder, and then I'm going to call it like test1.py. And then I press, go up here to run, and run it, or I type F5. And then the output, there's no plot for this one. The output just comes here. It says it's a run file. There's no errors, which is good. And it just prints out A times B equals, and it computed it, 42.599. Now, I don't know why the floating variables have all these 9s, but basically it means 42.6, which is correct. So it's slightly wrong here. But if you ignore all the 9s, it's done it right. Okay, so that's an example of multiplying. Next, I want to show functions. So let's make a function which adds two things. So the way I'm going to do that is I'm going to do def, which is defines, a function which I'll call add2. And it has an argument there which is x. And I put a colon. And then I do like space, 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 4 spaces. So now every time I indent by 4 spaces, that's inside this definition. Now this one's just going to be very simple. There's only one line to this function, which is return x plus 2. And that's it. So now that I'm done defining a function, I'm not going to indent the next line. I'm going to say C equals add a new C, add 2 to things it already knows, which is, let's call it B. Okay. And now we'll again print this function on B is space, comma, I don't like all these comments that pop up, C. So again, save it, run it. Okay, so it's still got the stuff from before. A times B equals, this function on B is 9.1, so that worked out. It took the B and it referred back to this function from before and added 7.1 plus 2. So you can make a function. Okay, next let's test out a trig function. So what if we say A equals 0, B equals pi over 2, and C equals pi. Now, the exclamation points that it's showing here is pi may be undefined, or it might be defined from the star imports. So this is one of those things where instead of doing import, I could have put pi there, but it should work. So now I could do, for example, print the sign of A of 0 is, and then I can put here comma, try again here, sin of A. And again, let's save it and let's run it, see what it does. The sign of 0 is 0.0. Okay, so that makes sense. And now let's do print the sine of pi over 2 is space sin of b. Do Control S on that and run it. This is sort of the 1.0. So that makes sense. So I'll just put a note here. Oops, in my hashtag note. The trig functions in Numpy use radians, not degrees. So that's a good little note in case you want to put comments in your code like that. We could do print the cosine of pi is space cos of c. Okay. Control S, we'll run it. -1, so that makes some sense. Okay. So now if I wanted to do this, I could just press pi, import pi only, and sine, Control S, run it. Then it gives me a name cos, no, right, forgot cos. So this is probably better. Now I've made all the exclamation points disappear. So sometimes what I do if I want to clean up my code at the end is I get rid of that asterisk at the top, and instead of importing a wildcard, I only import the functions that I actually am going to need in my code. But it sort of matters if, whether or not you care about the style of your Python code or whether it just works. If you just want it to work, then use wildcards all you like. So that's my little introduction today. Good luck with your coding this week. I hope it goes well, and I'll see you next week.